Alright, let's talk about something we all use every single day, but probably never give a second thought to. The road. It's that gray or black ribbon that gets us from point A to point B. We drive on it, we spill coffee on it, and we curse it when we hit a pothole. But this humble servant of our daily commute is the backbone of our entire society. Without these sprawling networks of asphalt and concrete, the lorries that deliver our food, the ambulances that race to save lives, and even the pizza delivery guy couldn't do their jobs. It's a fundamental piece of infrastructure, a testament to human ingenuity that connects us all, making modern life possible. It's a dirty, thankless, but absolutely essential job to build and maintain them. Now, not all roads are created equal. You've probably noticed some are black and a bit soft, especially on a hot summer day. That's asphalt, or what the experts call flexible pavement. But then you have the other kind, the pale gray, rigid giant, the concrete road. Think of it as the heavyweight champion of the paving world. It doesn't bend or flex under pressure, it stands its ground. These are the roads built for the long haul, designed to take a beating from heavy lorries and the relentless forces of Mother Nature without flinching. They are a different beast altogether, built with a different philosophy, a different set of materials, and a whole lot of hard work. So why choose concrete? Well, it all comes down to strength and longevity. While an asphalt road might be cheaper and quicker to lay down initially, it's like buying a cheap pair of work boots. They'll get the job done for a while, but soon enough they'll wear out, get holes, and need replacing. A concrete road, on the other hand, is like investing in a pair of custom-made, steel-toed leather boots. It costs more up front and takes more effort to break in, but it's built to last for decades. Engineers and city planners choose concrete for the most demanding jobs, where reliability isn't just a nice-to-have, it's a necessity. When you're driving down a major motorway, chances are you're rolling over concrete. It's the go-to material for the arteries of our nation's transport system. The sheer volume of traffic, from family cars to 40-ton articulated lorries, demands a surface that can distribute that immense weight effectively and endure constant punishment. A concrete slab spreads the load over a much wider area of the ground beneath it, preventing the kind of rutting and deformation you often see on lesser roads. It's a simple principle of physics, put to work on a massive scale to keep our country moving, day in and day out. It's a tough job, and it requires a tough material. Let's get our hands dirty and look at what's actually under your tires. A concrete road isn't just a simple slab of concrete poured onto the dirt. It's a carefully engineered system, a layer cake of different materials, each with a specific job to do. At the very bottom you have the subgrade. That's the natural earth, the foundation of the whole operation. It has to be compacted and prepared properly, or everything on top of it will eventually fail. It's the unsung hero that holds everything up. If the subgrade is weak or unstable, it doesn't matter how good the concrete is, you're building your house on sand, and that never ends well. On top of that prepared earth, we place the subbase layer. This is usually made of crushed stone, gravel, or sometimes recycled concrete. Its main role is to provide a stable platform for the concrete slab and to help with drainage. Water is the mortal enemy of any road. If it gets trapped underneath, it can freeze, expand, and wreck the whole structure from below. The subbase acts like a French drain, giving that water a path to escape and keeping the foundation solid and dry. It's the crucial buffer zone that protects the expensive concrete layer from the unpredictable moods of the ground beneath it. Now let's talk about the main types of concrete pavement you'll encounter. The most common is jointed plain concrete pavement, or JPCP. You know this one. It's the road made of distinct rectangular slabs with visible joints or gaps between them. These joints are there for a reason. Concrete expands when it's hot and shrinks when it's cold, and these gaps give it room to breathe without cracking itself to pieces. They are the engineered weak points that control where the cracking happens, keeping the main body of the slab intact. Sometimes, metal bars called dowels are placed across these joints to help transfer the load from one slab to the next. Then you have continuously reinforced concrete pavement, or CRCP. This type is a bit different. It's built as one long, continuous slab with a massive amount of steel reinforcement running through it. The idea here isn't to prevent cracking, but to embrace it. The steel holds the slab together so tightly that it develops thousands of tiny hairline cracks instead of large, destructive ones. These micro cracks are so fine they don't affect the road's strength or smoothness. It's a more expensive and complex method, but it results in a very smooth ride with fewer of those classic thump-thump sounds as you drive over joints. It's the premium option for high-traffic motorways where performance is everything. Building one of these concrete behemoths is a job that requires precision, brute force, and a whole lot of coordination. It all starts long before the first mixer truck arrives. The first step, and arguably the most important, is subgrade preparation. Crews come in with heavy machinery, graders, bulldozers, and massive rollers, to clear, level, and compact the native soil. They are essentially manufacturing a perfectly flat and stable earth foundation. Soil scientists test its density and moisture content to make sure it can handle the immense weight it's about to support for the next 40 years. Get this part wrong, and you're just wasting a whole lot of time and concrete. Next comes the placement of the sub-base layer. Lorry after lorry dumps piles of crushed aggregate, which is then spread evenly by graders to a precise thickness. Once again, the rollers come out to compact this layer until it's rock solid. While this is happening, another crew is busy setting up the formwork. These are temporary wooden or steel barriers that act as a mold, holding the wet concrete in place and defining the edges of the road slabs. For a big motorway project, they often use a massive automated machine called a slip-form paver, which crawls along slowly, creating the road's shape as it goes without needing fixed forms. Then the main event, the pour. A fleet of concrete mixer trucks arrives in a carefully choreographed sequence to ensure a continuous supply of fresh concrete. The concrete is poured between the forms or into the front of the slip-form paver. As it's laid down, powerful vibrators are used to consolidate the concrete, removing any air pockets and ensuring it settles into a dense, strong mass. This is a critical step. Trapped air creates weak spots that can lead to failure down the line. It's a messy, noisy, and intense process, where the clock is always ticking before the concrete starts to set. Finally, we have the finishing and curing stage. Right after the concrete is leveled, a series of finishing tools are used to create the final texture on the surface. Sometimes a burlap drag is pulled across it for a rough finish, or grooves are cut into it to improve skid resistance and reduce tire noise. Then comes the most patient part of the job: curing. The fresh concrete must be protected from drying out too quickly. Curing compounds are sprayed on top, or it's covered with wet blankets. This slow-drying process is what allows the concrete to achieve its maximum strength. It's not just about pouring concrete, it's about giving it the time and the right conditions to become a road. Like any tool for a tough job, concrete roads come with their own set of pros and cons. You have to weigh them up to decide if it's the right choice. On the good side, the biggest advantage is durability. These roads are incredibly strong and can last for 30, 40, or even 50 years with proper maintenance. They don't get ruts or potholes nearly as easily as asphalt, which means they can handle the constant pounding of heavy lorry traffic on major motorways and at industrial ports. This longevity is a huge selling point when you're thinking about the total cost over the life of the road. Another big plus is safety and efficiency. The light color of concrete reflects more light than dark asphalt, which improves visibility at night and can reduce the need for expensive street lighting. This makes the roads safer for drivers in low-light conditions. Furthermore, because concrete is a rigid surface, it doesn't flex under the weight of a vehicle. This means there's slightly less rolling resistance for tires, which can lead to modest fuel savings for the millions of cars and lorries that use the road over its lifetime. It might seem small, but when you multiply it by thousands of vehicles a day for decades, it adds up. Now, for the bad and the ugly. The most significant disadvantage is the initial cost. Building a concrete road is expensive, period. The materials, the specialized equipment like slip-form pavers, and the longer construction time all contribute to a much higher upfront investment compared to asphalt. This high-ticket price can be a major hurdle for local councils with tight budgets, even if the long-term savings are clear. The construction process is also more complex and disruptive, often requiring longer road closures, which is never popular with the public. Then there's the issue of repairs and ride quality. While concrete roads are durable, when they do fail, repairs can be a real headache. You can't just patch a hole easily. You often have to cut out and replace an entire slab, which is a slow, costly, and noisy process. And let's be honest, they can be louder to drive on. The noise from tires rolling over the textured surface and the thump-thump of crossing the joints can be more noticeable than on a smooth asphalt road. While modern techniques have reduced this, it's still a common complaint from people who live nearby. It's a trade-off: strength for serenity. So, you've built this expensive, durable road. You can't just walk away and forget about it. Maintenance is key to making sure it reaches its full 40-year lifespan. The most common job is joint sealing. The sealant in the gaps between slabs needs to be inspected and replaced every few years. This prevents water and incompressible debris like stones from getting into the joints, which could cause the slabs to crack or shift under pressure. It's a bit like the caulking around your bathtub, a small, simple job that prevents a much bigger, more expensive problem later on. When damage does occur, the repair method depends on the severity. For smaller issues like surface spalling or minor cracks, crews can use epoxy injections or apply a special cement-based patch. For more serious problems like a shattered slab, there's no choice but to perform a full-depth repair. This is major surgery. A crew comes in with giant concrete saws to cut out the entire damaged slab, breaks it up with jackhammers, removes the debris, prepares the subbase, and then pours a brand new slab in its place. It's a disruptive but necessary procedure to maintain the integrity of the entire road. The world of concrete is not standing still. There are some fascinating innovations making these roads even better. One of the biggest trends is the use of recycled materials. Old demolished concrete can be crushed up and used as the aggregate in the subbase or even in the new concrete mix itself, reducing landfill waste and the need to quarry new materials. Engineers are also experimenting with things like pervious concrete, which has a porous structure that allows rainwater to drain right through it, reducing surface runoff and recharging groundwater. It's like building a road that's also a drain. Perhaps the most exciting development is self-healing concrete. Imagine a road that could fix its own cracks. Scientists are developing concrete that contains tiny capsules of bacteria and nutrients. When a crack forms and water gets in, it activates the bacteria, which then produce limestone, effectively sealing the crack from the inside out. This technology is still in its early days, but it has the potential to revolutionize road maintenance, making our infrastructure smarter and far more resilient. These innovations show that even something as old and seemingly simple as concrete still has a few tricks up its sleeve. It's a testament to the hard work of people trying to build a better, more durable world from the ground up.